All right, honors Algebra 2. How are we doing? This is actually your last notes video because on Friday, I'm going to have a little review that I just made up. It's got 15 2x2s and 3 3x3s. That's going to serve as another really good test review because we're gonna get at that test relatively soon next week. All the due dates are now in Skyward updated. I will see you on Monday the 1st. All right, I will be back. Yay, yay. But as one does with surgery, I've got to have another follow-up appointment with the doctor to get an x-ray done on my foot, see how everything's healing. Everything is healing great. Surgeon said it's the best we could hope for. Biopsy came back great too, so all is looking good, but little more, intrusive surgery than I've had before, so I've got to follow up with the doc quite often. So long story short, I will not be here on Tuesday the 9th. So I was trying to make that happen on Veterans Day when we were out, but I could not. So that changed the schedule a little bit. If you look at Skyward, you might have written down some due dates in your your planner. That has sort of changed some of the due dates for your benefit, I think, because of when I'm going to be out. All right, so let's go to page 15. For whatever reason, I don't know if I had too many videos. I think my storage was getting a little close to maxing out, so I just cut off your video. So go back to page 15. Multiply those matrices. Again, you can use the calculator. I will help you more with the calculator when I get back, because in fact, I'm going to have us pause on solving systems using matrix inverses, because you've not taken your Chapter 3 test, Part 1 test yet, so we're going to pause on that. So multiply the matrices. Again, you do the first row by the first column. -3 times -1 is 3, plus 4 times a -3 is a -12, plus 0 times 1 is 0. Add those up. That's first row, first column. First row, second column, you can see the work I did here. Second row, first column, you can see the work I did right here. And second row, second column, 1 times 2 is 2, plus 2 times 0 is 0, plus 5 times -2 is a -10. Add those together, -8. All right, and then here's the answer to 14. 14. Can I multiply? I have a 1 by 4 and a 4 by 2, so I can. I'm going to get simply a 1 by 2, because I only have one row. First row by the first column, this times this, plus this times this, plus this times this, plus this times this, is 9. First row by the second column, this times this, plus this times this, times this, times this, plus this times this, you get -1. Again, you can use your calculator. We'll talk about that when I'm back. All right, so where are we going to next? We're going to go to page 17. 17, that's the second to last page. So write the system as an augmented matrix. Do not solve it. Again, yours has the set notation. That's because Microsoft equation editor, which is fantastic. But at that time, I don't know if it still does, doesn't allow you to use type in a matrix as a big bracket. Their matrices are, I think it's set notation. Or what I was trying to do was in set notation with the line straight down. All right, so it's 5x minus 3y equals -9. 2x plus 5y equals 17. So easy. Next one is 2x minus 3z is a -7. -2y plus 3z is equal to 8. 5x minus 6y is equal to 12. Write as an augmented matrix. 3, -5. You can have a dotted line or a solid line. Doesn't matter. -19. 4, 8. You gotta have some sort of line to show this means equals, and these are your constants. -25. All right. 2x minus 3y plus 5z is 21. Then you have 3 for x, 6 for z, 0 for y. Put the 0 in. Equals 30. 0x, 4y, -7z equals -32. All right, and then on the second to last page, just adding these two matrices together. -2 plus a -5 is a -7. 19 plus -8 is 11. -7 plus 4 is a -3. 2 plus a -3 is a -1. 6 plus -7 is a -1. 5 plus -13 is a -5. All right. And 7 minus negative 8 is 15, plus 3, 18. Negative 2 minus 2 is negative 4, plus 4, 0. Negative 6 minus 7 is a negative 13. Negative 13 plus negative 5 is negative 18. 5 minus negative 4 is 9. 9 plus 7 is 16. All right, so that is page 17. I think there might be more. But before, we need to say hi to some sponsors in the house. Cliff Bar, 12-pack Cool Mint Chocolate. Noon Electrolyte. It's kind of bright. Nice day outside. There we go. Noon Electrolyte hydration tablets, and then Living gluten-free, baby. Yes, Aldi's finest chocolate chip soft bake cookies, as seen in Good Housekeeping. All right, so that's there you go. Page 17. We are continuing on page 17. Number 7. All right, so you're obviously allowed to use on this graphing calculator, and you'll want to use the matrix sometimes. I would not use the matrix application for this. Just multiply everything in this matrix by 4, everything in this matrix by 3, and then add up the corresponding cells, elements. And you get your answer. That should be pretty easy to see on number 7. And on 8, multiply the first matrix, everything in it, by negative 5. Multiply everything in. Second matrix by 3. Again, I can add or subtract 2 matrices when they have the same dimensions. And then, and add up everything, or multiply everything in the third matrix by 2. And there we go. 5 plus a negative 3 is a negative 2. Is 2. 2 plus negative 4 is negative 2. Add those together, and you get negative 13. Add this together, and you get 8. Add those together, and you get 22. All right. 9 and 10. Find the determinant of each matrix. So the determinant of A. Negative 1, 4 times negative 1 is 4. Okay, again, you do the difference of the cross products. Should have told you that first. So this times this minus that times that. Determinant is simply difference of the cross products. Negative 4 times negative 1 minus 5 times negative 2. Difference of the cross products, 2 times 10 minus 5 times 1. All right. All right, so we're going to go to page 7, and we're not going to finish all of this section, but section 3.8 is solving systems using inverse matrices. So if matrix A is this matrix, it's a little bit different than when we did the determinant, but if matrix A is this matrix, then A inverse, the inverse matrix, is 1 over the determinant of A, so you can see why determinant of A is going to be pretty important. 1 over the determinant of A. If we look at this new matrix here, so A and D switch positions, and C and B become their opposite values. That's what's happening there. And then this is a number, so it might be like 1 over 3. You would multiply everything in here by a third. All right? 1 over the determinant of A of this new, switching there. All right? So by hand, let's do this by hand. Again, your calculator can help you out. I'll show you when I get back. By hand, find A inverse. So that's A. First off, let's find the determinant of A. The determinant of A is still the difference of cross products. 3 times 1 minus negative 2 times a negative 1. Well, be careful. Negative times a negative is positive. You're still subtracting it. The determinant is just 1. So, Yogi, nope, buddy. You've been warned. No bathroom for you. Unless we start barking. A inverse is equal to 1 over 1. That's the determinant of A of what happens? 1 and 3 switch positions. Look at the arrows. 1 and 3 switch positions. And these two become their opposite values. All right. Well, I'm just multiplying everything by 1 because that's what 1 over 1 is. So this is A inverse. This is the inverse matrix of A. Now, note when you multiply A and A inverse, what happens? First row by the first column. 3 times 1 is 3 plus negative 2 is 1. Do this with this. 3 times 2 is 6. Negative 2 times 3 is a negative 6, 0. Do the first row with, or second row with the first column. Negative 1 times 1 is 1, plus 1 times 1 is 0. Negative 1 times 2 is a negative 2. 1 times 3 is 3. 1. That's the identity matrix. You saw that on one page. 1's in the diagonal, 0's everywhere else is the identity matrix. It's like when you do, 6 times 1 over 6, you get 1. All right, so find x inverse if x is equal to this matrix. Find the inverse matrix. That's what x inverse means. 3 times 4 minus 1, negative 1 times 3. Your determinant is 15. So x inverse is equal to 1 over 15, one other determinant of, you're going to switch these, and you're going to give these the opposite sign. You multiply everything by 1/15. Negative 3 over 15 and 3 over 15, that's a fifth, plus or minus. Again, I'll show you how we can utilize our calculator, but you're going to take more math classes, linear algebra in the future. Definitely going to do this by hand. Okay, so very good. This can be sort of a quick video here because if you go to 3 and 4, at the bottom of that page it says use, what is that? AX equals B, X equals A inverse B. We're just going to solve 3 and 4. Folks, if I gave you a 2 by 2, just solve it. So I multiplied the top equation by 4 and the bottom, nope. Multiply top one by 3 and the bottom by 4. I want to get rid of the x's through subtraction. I get y is a negative 3. And I got 3x plus 8y is a negative 6. Plug negative 3 in for x, and I get, for y, and I get x is 6. We don't need to use the matrix application for this. This is good practice for your Chapter 3, Part 1 test, which we need to take first, because in normal years, you take the test before we move on, right, to this part. But this fall, been a little less than normal for your teacher. So I want to get rid of the x's, multiply top one by 3, the bottom one by 5, and I'm going to add them up. That is a negative 17y is equal to a negative 85. Y is a plus and 5. I'm using the original equation 1, plugging 5 in for y there. And I get x is a negative 2. All right. So, probably look at this. No, we got to take a test first. So never mind. Find the additive inverse. Go to page 11, example 2. Folks, the additive inverse is just what makes, now the additive inverse, think about regular addition. What's the inverse, additive inverse of 5? It's a negative 5. When you add them together, you get 0. It's not like the multiplicative inverse. When you multiply them, you get 1. So they're just, every single number element is just going to be the opposite. Because 2 plus negative 2 is 0. 8 plus negative 8 is 0. Negative 3 plus 3 is 0. 0 plus 0 is 0. So this is the additive inverse. Just the opposite values. Here's your equation, or your matrix. Here's the additive inverse. Everything is just opposite. Easy peasy. And I believe, yes, we will be finishing on page 15, number 11. It's in, I think, one of the quiz reviews. It's this one. What's A inverse? This one a little bit of a tricky fella. So when we solved systems, sometimes we would get no solution, all real numbers. And that can happen always. And here is what happens when I try to find A inverse. If I find the determinant, difference of the cross products, the determinant is 0. So, So if I tried to do this, okay, it is 1 over 0 of, the flipping. I don't have to write these out because this can't, is everything negative? That's interesting. This can't happen. I can't multiply this by 1 over 0. That's undefined. Undefined times this matrix. So A has no inverse. So if a matrix has a determinant of 0, it has no inverse. All right, so it has no inverse. So So that is it. That's my answer. So what you're going to do tomorrow, and I need you guys to do a great job with this, all right, is you are going to do this review. I'm gonna email it to you. You can write it down on a separate sheet of paper. That's all right. We're gonna practice these. It's got 15 on this first page and 3 3x3s. Just made these up. They should be good. If there isn't an issue, then I did some wrong arithmetic. But these are just totally made up. All right. So you want to practice these because your exam or your test for this is next week. All right. And this is going to be for Friday. So Friday is going to be no video. You're just going to practice this. See if you can do this on your own because your test is going to be on your own. All right. Anyway, this is Yak Math Videos, and we are signing out.